All right, I want to go ahead and talk about four basic definitions here: reflection, refraction, diffraction, interference, very quickly. Reflection is whenever a wave bounces off of a boundary. We'll get more into the complexities with that, but a light wave, a sound wave, anything comes in. Here are the wave fronts being shown. Here's the ray. It comes in, it hits a boundary, whether it's a mirror, whether it's whatever it is, if it's ocean waves, maybe it's a seawall, and it will bounce off, such that the incident angle measured to the normal, that's an important idea there, the incident angle measured to the normal is equal to the reflected ray measured to the normal. Refraction is when a wave bends due to a change in velocity when entering a medium at an angle, a different medium at an angle. And I'll get into the idea behind that in lesson 3. But here I have, let's say, light coming in and then moving into, let's say, glass here. And whenever it does, it hits and it bends. This is why whenever you look at a glass of water and you have a straw in there, it looks like the straw is broken. It actually seems like the straw bends. Whenever you know that's not the case, it also explains why swimming pools look shallower than they actually are. It's because the light bends whenever it goes into a new medium due to a change in velocity. More to come on that later, though. Diffraction explains how light or any type of wave, sound, anything else, spreads back out or spreads around things. Just because there's a barrier, and let's say there's only one small opening, doesn't mean that the light then or sound would just go straight through. By the way, this is not how you form a laser. If you shine light at a small slit, you will not get a laser from it. In fact, the light, while it may seem that the highest intensity is straight ahead, which it is, but the light or sound or any other type of wave begins to spread back out, almost like this is a brand new source or a brand new point source there. So any opening, a small slit, anything like that, light continues to spread back out, or sound or any other type of wave. Water waves, doesn't matter, will start to spread back out. That's diffraction. Diffraction also explains how light or sound or anything else will gradually reform around a barrier. So if you put something in there, it will actually start bending back around to where it's almost like the barrier never existed. If you have a really thin slit, it actually becomes like a new point source, just like it was the light itself. Interference occurs whenever two waves intersect and they add. Now, for good interference to occur, the waves will be coherent. Another way to put this, the waves will have the same frequency wavelength. They'll be the same wave, just starting from two different locations. So here I have water waves being formed by two different, if you will, bobs from a fishing pole. It could be two speakers, right, sound speakers. It could be two light sources, as long as they're identical there. And the waves, where they intersect, you can see the intersections occurring, will add. Sometimes they will add constructively, meaning that the wave will get bigger. Sometimes they'll cancel each other out, destructive interference. But more to come on that later as well. All right, so those are your basic definitions. In the next few lessons, we're going to actually get into the nitty-gritty of this stuff.